Well, hello, everyone. Thank you for joining this webinar. This session is going to be about Git, just to check that you are on the right session. And yeah, let's just go right ahead. If you have any questions, you can write them on Slido, and I'll reserve some time at the end to answer them. All right, let's get started. My name is Enrico Campidoglio. I work as a freelancer. This is me freelancing from home, especially these days. But we're not here to talk about me. We are here to talk about Git. And in particular, we want to see that, so we know that learning Git today is pretty easy. There are books, there are online courses, there are tutorials, heck, there are even podcasts about Git. So you can safely say that it has never been a better time to learn Git. However, while everybody is busy telling you how Git works, there isn't that much guidance about how to use Git while you're working with others. But it's like learning to play the piano. So you learn how to play individual notes, but then you're not able to play a full song. So what we need is guidance, help. But then you might wonder, okay, why would you need help in using a version control system? And you might be right asking that question, because traditional source control systems like CVS and Perforce, Subversion, and even TFS, they were pretty much telling you how to use them by virtue of their design. So you didn't really have that much choice on how to do version control. It was dictated by the version control system. Git, on the other hand, doesn't really tell you how to use it. It says it right in the name. Git is just a content tracker. It doesn't really care how you use it in the context of a version control system. So it's more like whatever works for you. And this leaves a wide gap in how people are using Git, because there is no defined way. But then the question becomes, okay, if there is no well-defined way to use Git, and you can use it pretty much any way you like, how do you know that you're using it properly? Or how do you know that you're getting the most value out of it? Well, the only thing you can do is observe what others are doing with Git, what works for them, and see if any of that applies to you. And this is exactly what I've done. For a few years now, I've been working with lots of different teams and lots of different projects. And I've observed how different ways of using Git has impacted these teams and these projects. And I've been basically writing this all down because it's good stuff, and kind of over time distilled it into a set of guidance. So what is this talk about? This talk is about a collection of habits and ideas that I've collected from working with people who are really good at using Git to improve their workflow. And when I talk about using Git, I don't mean just in the context of a team, but also on an individual level. So these are habits and ideas. They work both individually and as a group. So let's get started. So I just mentioned that you can use Git kind of at two levels: on your own, like on your own machine, and while collaborating with others. So it makes sense to divide these ideas and habits and techniques into two kinds. What I call personal workflows, that is things you do with Git when you are on your own machine, and things that you do while you are working with others in a team. So throughout this presentation, I'll be dividing what I talk about into these two categories. And to be more specific, I'll give you three techniques or habits that you can use on your own individually. And then I'll give you three ideas, things to think about in the context of a team while you are deciding how you want to use Git in your project. So in total, 6 ideas. And let's start with the individual workflows. So let me jump over. What I have here, I have slides on the right. Well, my right might be your left. So you just keep that in mind. And on the other side, I have a terminal. Let me just briefly mention that I'll be using Git from the command line throughout this presentation. However, most of the things I'll be talking about, they apply just as well if you're using Git from a graphical user interface. And when I talk about something that only applies to the command line, I'll say it. So the first habit or a good thing to do at an individual level while using with Git is to get comfortable. Now, we know that Git is a pretty complicated tool to use already, so there is no reason to make it any harder to use than it already is. And this means configure your environment so that Git is a comfortable tool to use. So what follows are a series of settings that I regularly apply on my Git installation if I'm on a new project or a new computer. And they really help using Git more effectively. So the first one is, and this applies if you're using Git from the command line, is to use a Git-aware prompt. There are a bunch of utilities that basically enrich your console, your shell prompt with information that are specific to your repository. Like, for example, which branch you're on, how many files you've changed, if there are any conflicts. And these, of course, depend on which command line prompt you're using. So if you're using PowerShell, excuse me, I'll recommend using a utility called pushgit. If you are using Linux, or if you're just using Linux on Windows, and you're using Bash, then bash git prompt is a really good one. And if you're looking for something cross-platform, then my personal favorite is Starship. And that's what you're looking at on the other side on the terminal. Starship is a cross-platform Git-aware prompt. And as a bonus, it's also written in Rust. So it doesn't get any cooler than that. So having a Git-aware prompt. Next one is having some pretty diffs. So if you're using Git, you'll be looking, well, if you're using source control in general, you'll be looking at a lot of diffs. And it makes sense to make them as readable as possible. And this means installing a utility that it's called diff so fancy. It's an npm module. And what it does is that it accepts input, it accepts a universal diff in text format, and it removes all the noise and makes it basically pretty to look at. So let me show you what I mean. After you have installed it, so you say npm install g diff so fancy, which are already done. What you do is that you configure your Git installation to basically pipe all the diff output through diff so fancy. So you say git config core, it's called pager in Git parlance. And you say, I'm gonna pass it to diff so fancy. And after this so fancy, it makes sense to page it to something like less, excuse me, to give you basically the ability to scroll up and down in the diff text. And what I usually do is that I send 3 options to less. The first one, called R, this one it will tell less to print control characters, for example, like line endings. And those things you absolutely want to see in your diff when you're looking at differences between 2 files. If just the line ending is changed, you want to see that. The next one is called F. And what this does is it tells less that if the diff you're looking at fits in one screen, then you can exit immediately instead of having you press Q every time to exit. The third option is X. And what this does is it basically clears the screen before printing the diff. So after you've done all this, you can basically say diff, for example, in this sample project I'm looking at, if I want to diff the commit that is before head compared to head, I get this. Let me just show you how it looks without. When you say no pager, diff head. So this is telling Git to just skip the pager. So this is how it usually looks like. Usually looks like on the bottom part, and on the top part is through diff so fancy. So if you don't think this is fancy, I don't know what you think is fancy. You see, it even highlights the exact character that changed between the 2 lines, while the regular diff does not. And it also removes the plus and minus, and it makes the header much more concise. So pretty diffs is something that effective teams and effective Git users absolutely have. The next one is, and is related to this, is making your patches more readable. So by default, when you're looking at a patch, Git will show you, and let me just show you again. It will show you exactly 2 lines before and after its change. Now, sometimes when you're looking at a diff, you want more context to be able to determine, for example, which function this line is. So you can tell Git to show you more lines around each diff by setting the diff context option. So in this case, so by default, you say diff.context, the default is 2. If you set it to 4, and then basically run the same command again, now you see that I have 4 lines around around the difference. And this, of course, you can set it to whatever you want. And this allows you to have more information around its difference. But I found that 4 is a number that, you know, doesn't make the diff too long, but usually it's enough to make sense of a individual diff. All right, let's move on to the next one. White space. Now, as programmers, we know that white space matters probably much more than any other part of life. So you absolutely want to handle it correctly. And Git has a bunch of built-in functionality to do exactly that. For example, Git can tell you if you have some invalid white space in your source code. All you have to do is tell it what should be considered invalid white space through the core.whitespace option. So for example, I usually set it to core whitespace. I set it to blank at end of line. That means I don't want any spaces at the end of a line. I don't want any spaces at the end of the file either. And this is not getting into the indentation, but I don't want any tabs in my indentation. I want to use spaces instead, as it should be, right? So this means that if, let me just open up the a source code file here, and let's make a change let's do this. We change this to, we change the string, and then we'll also add a bunch of white space at the end. All right, so now you see that Starship is showing me that I have one modified files already without having to do git status, which is pretty nice. And if I do git diff -- check, having set the core whitespace option, Git will show me, you have trailing whitespace. And it shows me exactly where in the file. Now, of course, I have the option to fix it, but I can also just go ahead and commit it. So let's do that, because I want to show you another thing you can do with whitespace. You say git commit all with the message some invalid whitespace. So now I've committed some invalid whitespace. One thing Git can do for you is that it can automatically fix any whitespace errors by doing a rebase. Why a rebase, you might wonder? Well, that's because when you're doing a rebase, Git will apply every change that is made in a commit one at a time on top of the previous commit. And that's a perfect time to make any modifications to the source file as it applies the next commit. So in this case, I want to say rebase, and let's start 2 commits before my latest one with the invalid whitespace. Actually, before we do that, let me show you how it looks like, the diff. So this is the commit I just made with the extra whitespace here. So we say git rebase 2 commits before my latest one, and then I say whitespace equals fix. So you see that Git has rewinded head to 2 commits ago, and then it applied the latest 2 commits. And now if I look at the latest one, you see that the whitespace is gone. So yeah, absolutely enable this in your project and use it, because there is nothing worse than having real changes mixed up with a lot of whitespace errors. All right. Next up is conflict handling. Of course, conflicts are a fact of life, and especially when you're doing source control with other people. And Git has some pretty nice built-in facilities to let you handle conflict. Now, by default, let me show you what I have here. I have two branches now, master that I'm on, and then I have one called feature. Now, I know that there is a conflict in that feature branch. So let's try to merge feature on master, and I get a conflict. Now, usually, what Git will do is that it will show you what each side of the conflict, how the particular line that is conflicting, Git will show you how it looks like on either side. So you can decide which one you want. So on the one side, I have a comma here. This is the conflicting line. And the other side, I don't have the comma, and they remove the exclamation mark over here. So at this point, I have to decide which one I want. So this is good in many cases, but sometimes when you are trying to decide which side of the conflict you want to choose, it's helpful to see how did this line look like before the conflict. So that means, how did this line look like on the latest commit before the two that are conflicting? The common parent. So this is called a 3-way merge. And this is one of the best features in Git, is that it has really good facilities to do a so-called 3-way merge. Why 3-way? Well, because you are comparing two sides, not only against each other, but you're comparing them to their common parent. So how do you do that? You tell Git that you want a conflict style. You set it to diff3. Now, by default, you say merge.conflict style. By default, this is set to merge, which is two-way merge, not three-way. And we can set it to merge.conflict style. We set it to diff3. Now we just abort this merge, and we'll do it again with the new option. So merge feature. Now I still have the conflict, and let's look at how the file looks like now. And you see that now I have a three-way merge. So not only am I comparing the two lines, but I'm also comparing them against how it looked like before. So you see before it didn't have a comma, but it had the exclamation mark, and then this side changed it by removing the exclamation mark, and this side changed it by adding the comma. And at this point, of course, I can decide how I want to resolve this conflict. Great. So let's remove this one. Cool. Next up, we have something called global ignores. Global ignore. So you know that every repository has some files that you don't want to track, and you tell Git what files you don't want to track by adding them to a .gitignore file. Now this can get pretty repetitive, especially if you're working with a lot of the same. So all your projects are using the same kind of programming language or frameworks, because they tend to have the same kind of temp files and files you don't want to track. So a very useful thing that many effective teams do is that they define a global ignore, and they put it somewhere else on their file system, like for example in the home directory. And then you can tell Git to read the git ignores instruction from this global file, as well as any additional git ignores that you put inside a particular repository. So this is a .NET Core 3.1 project. As you can see, Starship is also telling me what kind of platform I'm working with in this particular project. And of course, you don't want to track like the bin and obj. So let me first show you how this repository looks like. I have like a source directory with a program, then I have a project file. Now, if we just build it, so this will create a bunch of, not working. But let's not worry about that for the moment, because we're gonna look at other things you can do to solve these kind of problems. But so never mind that it's not working. The important thing is that it has created bin and obj directory that you absolutely do not want to track. And as you can see, I can see that there are some untracked files now in my working directory. So for example, the obj. Now, obj and bin are common to all .NET projects. So this is a good candidate to put in the global ignore file. So let's, so I have it in my home directory. If you're on Windows, that will be C users and then, then your username. So git ignore _ global. And right now it just has these two files, these two entries. I just tell it that I don't want to track any bin or obj directories, never ever. So I just put them in the global one. And now, as you can see, I didn't have to do anything, and it just shows them as ignored. And that's because, of course, I set the excludes files, exclude files. What is it called? Exclude files. It's called in the global. Okay, let me just find it. Config global list grep exclude. There it is. core.excludes file, not files, sorry. And you give it the path to where it is. All right. Next one is a little bit of an unknown feature. So if you're using tags, if your team is using tags to version your software, which you should, it might be frustrating that Git doesn't automatically push new tags when you do a push operation. If you want to do that, you'll have to explicitly push them or add the follow tags option. Well, one of the things that I've seen most teams do when they're working with tags is that they enable the automatic push of new tags by setting the config push.follow tags option to true, and that every time you create a brand new tag and you do a push, Git will automatically push the commit and the tag as well. So nothing really fancy here, but something that you should be aware of. Okay, so this is all everything I've showed you right now is in the first of the three individual workflows techniques. The next one is to craft your history. So something that I've seen effective teams do is that they really take care of their history. And that means making sure that the history is readable and that it clearly is a track of how the software, how the source code changed throughout the project and why it changed in the way it did. So it must be a clear record of what happened. And that means creating good commits. Now you might say, okay, yeah, but what's a good commit? Well, after years of reflection, I eventually arrived at the conclusion that good commits are ACID. Now, if you work with databases, you might recognize this acronym. However, in the context of Git, it takes a whole different meaning. So what are ACID commits? Well, let's start with the A. The A is good commits are autonomous. That means commit should make a logical change that is independent from other commits. Okay, that makes sense, but how do you do it in practice then? Yeah, well, you use something called a patch add or a patch commit. What does it mean? For example, let's say that I want to open up this file and I'm in this file and I'm working and I want to make a couple of changes. For example, I know that this is probably not used, or actually it's not used. So let's remove it. So I remove the using statement, while at the same time, maybe I want to add an exclamation mark over here. So I made two kinds of changes. One, where I changed a string that's visible to the user, and then I removed something that is basically just a cleanup. Now, these two things are typically things that you want into two separate commits, because while this affects the UI of your program, this one is completely visible to only programmers, and you want to treat them individually. So what do? Let's save this file. If you do a diff, of course, I see that I have two differences. What I want to do is that I want to commit them individually, even though they are in the same file. So what do I do is that instead of just doing add, I say add p or patch. And what this allows me to do is that Git is going to ask me, okay, I see that you have two changes in this file. Do you want to commit this one? And you say, no. What about this? Do you want to commit this one? And I say, yes, absolutely, let's commit that one. So now, if I do git status, you see that my file is at the same time, part of it is staged and part of it is still in my working directory. And if I want to see what's only staged, I say git the diff -- cached. And that's what I've staged. And if I want to see what's in my working directory, I say just git diff. And graphical Git clients will also show this. So it's going to be pretty clear what you have staged and what you have not staged. So at this point, I can say git commit, and then I say I changed the read line string. And then at this point, I can just add the rest of the, well, let's do a patch commit, even if there is just one, just to show you how it works again. So yeah, would you want to, do you want to commit this? And I say yes. And then I say commit removes an unused import statement. And then, so then I've logically separated my commits. And notice that I didn't have to think about it as I was editing my file. It's something that I did afterwards. So this is a very big difference between Git and other source control systems, in that if you're using Subversion or TFS, you know that to do this kind of thing, you needed to think ahead and do one change at a time, check in, and then do the other change. And you kind of had to keep that stuff in your head. While in Git, I can just edit as I want, and at the time of commit, then I can split them up. So this frees me from having to think about source control as I'm editing the file, which is something to keep in mind. So autonomous commits. The next is the C, and it stands for compatible. ACID commits are compatible in the sense that they should not break the state of your project. So you should be able to cherry pick, pick a commit and apply it in your branch without being afraid that it should break tests or no longer compile. But how do you make sure that every individual commit doesn't add any errors? Well, you have a couple of ways to do that. First one is to use the stash. So stash, you probably already know what it is. Stash takes the files that are modified in your working directory and saves them separately and put them in a kind of a different location called the stash. Now, I don't usually use the stash because problem with the stash is that it tends to grow over time, and then you're kind of, it's like putting stuff in the closet, and then suddenly you open it up and stuff, comes at you. So, but in this case, I use the stash to verify that my changes do not break anything. So, for example, let me open up this file again. And let's make a change. For example, let's remove this, the public. And then let me open up another file, for example, the project file. And let's rename this to Hello World. This is just a project file. Perfect. So now I have two modified files. I want to verify, I want to commit the program just by itself and the change in the project file just by itself, because every commit should be autonomous. So, but how do I verify that my change doesn't break anything? Well, I add the file I want to commit to the staging area. So now I've prepared my commit, but I still have a lot of files. I still have a file modified in my working directory. How do I get rid of that? I say stash, save, and then I pass the option keep index. So what this does is that exactly what it says. It's gonna stash my project file that is in my working directory as modified, but it will not do anything with what I already said I'm about to commit. So let's do that. And you see that now I just have my indexed, my staged file, and my project file is stashed away. So at this point, I can run the tests, I can run the build script, and I know that the only files that are in my working directory are the files that are about to be committed. So if everything works, then I know that I haven't broken anything. And when when I'm done, well, let's just first commit this. What did I do? Oh yeah, I removed removes the public keyword. Good change. And then I can simply put back the changes from the stash with git stash pop. And now I have my project file back. Very powerful technique to use, something that I use all the time, and something that I've seen a lot of teams do as well on an individual level. But of course, this is adding a little bit of work to your workflow. Let me just get rid of the change. This is adding some steps. So what can you do if you have already committed everything and you haven't used this technique? So how can you ensure that every individual commit doesn't break your software? Meet Rebase again. Rebase is a kind of a jack of all trades in Git parlance. It does everything. We saw that it can fix the white space for you, and it can also help you ensure that every individual commit doesn't break your source code with something called the exec option. So what you can do is basically say, during a rebase, I want Git to execute a command that I pass after each commit. And how does it do that? Well, let me show you by turning it into an interactive commit where we can see the list of commits. And so in this case, I don't have any tests, unfortunately, but I do have a build, a project file that I can build. So what I'm saying is that I want Git to run .NET build after every commit. Which commits? Well, let's start from the beginning. So I'm going to say rebase root, which means take all the commits that are in this current branch and run .NET build. So what it does is that, as you see, it basically appends this line after every commit that I selected in the range, in this case, everything. So what I have to do now is just save this file, and Git is going to run the build automatically. So the first one goes through, no problem. Second one fails, as you saw earlier. So right now I am on the exact commit that broke the build. And I can see that the problem is that the console doesn't have a readln method. So this is just a typo. But you see that Git is telling me the execution of your program, of your command has failed, and we are at the commit that introduced the error, commit 4 of 16. So let's look at this commit, and indeed, this is the commit that added the line that created the problem. So what can I do now? I can open this program, this source code file. I can fix the problem, basically. Let's take a look. Yeah. I can even just run the build script again, just to make sure that everything works. Then I can stage it. And then I don't want to create a new commit, but I want to basically modify the commit that I'm on right now. So I say git commit amend. And if you don't want to change the message, you can basically say no edit. And now if I look at the file, if I look at the commit, it's like the error never happened. So at this point, I can say git rebase continue, and Git will, continue on through all the others, running the build. Oh, now we have another problem, but you already seen the drill, so there is no point in doing it again. Otherwise, we'll be here till tomorrow. So just rebort everything. So rebase exec, very good way to ensure that every commit does not break, is compatible. Next one is the I, and that's incremental. What's an incremental commit? Well, an incremental commit is a commit that shows clearly the progression you have made with your changes. What does it mean? It means that every commit should basically show you your thought process as you went through about your changes. How do you ensure that your commits are incremental? Well, you use an interactive rebase. So let me show you again. Let's say that I want to push these latest 3 commits. And while I'm here, I can decide that, you know, this one should come before that one. And because this is the progress that I've made through my changes. For example, if this is a cleanup and this is the thing I want to do first, then I want to make a change that is actually user-related change. And then maybe I want, well, you know what? This is also a cleanup. So let's move it also before. So I've remove, and changed. And basically I'm just reordering my commits before I share them to show some kind of logical progression. This means taking care of your history. The last one is the D, and it stands for documented. So yeah, when commit messages do matter, they matter a lot. So let's make sure that they explain not necessarily just what changed, but why it did. And let me just show you what I mean. So when you are writing a commit message, there is a well-defined format for how commits should be formatted. And it's like this. The first line is called the subject, and it should be at the most 50 characters. So, and if you're using something like, well, if you're using a Git GUI, it's going to show you. And on the command line, if you're using something like Vim, if I write more text here, you see that it changed color at some point. This is the 51 character. So it's clearly showing me that the first line should be at the most 50 characters. So it should be the summary. If you want to provide more information about your change, you should leave an empty line over here. And then you have the so-called body where you can explain why this changed and provide any more resources. For example, links to other commits and etc. One quick tip here, if you're doing pair programming in your team and you want to record who was involved in the pair programming session, now Git only records one author. So what you can do, and I've seen some teams do that to great effect, is that they, at the end of the commit message, they write the names of the people involved in the pair programming. So, for example, yeah, you get the point. Bar and Buzz. So you basically name everyone who was involved in the pair programming session, and you record it as part of the commit message, but you do it in a consistent format. So you can easily later find out who was involved in this change. Pretty nice thing to do, which doesn't take a lot of effort. So these are the ACID commits. So to recap, ACID commits are autonomous, they are compatible, they are incremental, and they are documented. Easy to remember. The next category of things you can do individually is to automate. Now, Git has a bunch of features to get stuff done quicker. So one thing to be effective is to let Git do the work for you. The first thing is having something called the alias function. So you know that you can create aliases in Git to kind of shorten the command. So instead of saying checkout, for example, you can write CO. And so I can say Git CO feature instead of Git checkout. So this is pretty nice, but it doesn't stop there. You can associate entire shell functions to a to an alias. So one of my favorite ones that I came up with a few years ago and I've been using ever since is what I call the undo alias. So what does it do? Undo basically defines a function called f. So this means that the alias should run a shell command. That's the exclamation mark. Then I define a shell function called f. It doesn't really matter what it's called. And the body of the function is I do a reset to the previous, I know this looks cryptic, but this resets my current branch to the previous commit in the ref log being the history of every commit that happened in your branch. And this is the parameter that I pass to the function. And then at the end of the function declaration, I just invoke it immediately afterwards. So this allows me, for example, if let me just commit an empty commit, so no changes. So let's make commit A, commit B, and then let me just use my alias to show you just the last 4 commits. So let's say that I want to undo these 2 commits. I can use my undo alias to say git undo and then pass how many commits ago, how many commits do you want to undo? That means how many times you want to undo. 2. So it's like pressing Control Z twice, 1, 2. And now, I used the wrong one. And now I don't have A and B anymore. So alias functions, very powerful way to associate complex shell functions to your aliases and speed up your workflow. The next one is what I call out of this and out of that. So this one I won't show you because I'm running out of time. Otherwise, I have lots of other things to tell you. So you might know that when you're doing a rebase, if you have some modified files in your working directory, Git will tell you, no, you can't rebase because you have files. Well, what autostash does is exactly what it says. If you're doing a rebase and you have modified files, it will automatically stash them away, do the rebase, and then put them back in, much like we did before with keep index, but it will do it automatically. Auto squash, this one is interesting. Let's say that you are working on your changes and then you realized that a few commits ago, you should have included another change. For example, let's say that in this one, I wanted to do something else, but I'm already made 2 commits afterwards, so I can't easily amend it. So what I can do is that I can make the change. So for example, yeah, let's do whatever. Let's remove the exclamation mark. So now I have a change that I know I wanted to include here instead. So what do I do? Instead of committing it into a new commit, well, I start by staging it, of course, and then I say commit fix up, and then I pass it the commit ID of the one that I want to include this change into. So of course I can find it like this, but an even quicker way is just by saying commit fix up :dash, looks like a disappointed emoji. And here I can just enter a portion of the commit message. So for example, let's say unused. And Git is going to find the commit that contains this word, get the commit hash, and create a new commit that starts with fix up and then the rest of the commit message. So now I have this. What I do next is that I do a rebase, an interactive rebase. Remember, like we did for reordering. And then I can just go back a few, and this commit will automatically be moved right underneath the one that it should be squashed into. And at this point, I can just save and it's going to do the squash. Of course, this comes really in handy if you have multiple commits that you want to squash into earlier ones, because they will automatically move into the right place. And now I have the squash commit. And this is what auto squash does. So lots of built-in useful features that you can enable and tap into. The next one is client-side hooks. Now, there are scripts you can write that will automatically run on your machine when some events occur. So, for example, the pre-commit will fire just before you are creating the commit, and you can use it to validate, for example, that you don't have an invalid white space. The other one will fire also before the commit is created, but will allow you to, for example, validate the commit message. So I have these files, they live in the .git directory called hooks. There are a bunch of them. I have one called commit message that I've implemented, and this is just a shell function that basically reads it will receive the entire commit message as a parameter, and then I can just verify that it's shorter than the designated 50 characters. And if it isn't, I get a warning and the possibility to modify it. So let me show you how it works. Let's create an empty commit, just not to have to make a change. And then I can write a really long message that is definitely longer than 50 characters. And then I get this warning that says, hey, your line should be 50 characters, but it was 72. Do you want to modify the message or just commit it? If I press yes, then you see that I can cut it at the right point. And if I press no, I can just ignore it. So client-side hooks, something that effective teams definitely distribute to everyone. And this speeds up their individual workflows because they catch errors before they get pushed into the common repository. And this is the last of the individual workflows tips. The next ones are related to teams workflows. So 3 categories here as well. Let's get right into it. The first one is related to branching. Now, I won't talk about specific Git workflows, like, for example, GitHub Flow or Git Flow. These are ideas and things to consider and think about as you are deciding which workflow suits your particular team and your particular project. So the first thing to think about is being aware that there are different kinds of branches. And what do I mean by that? I mean that branches come in 2 flavors. There are long-running branches and there are topic branches. Now, long-running branches is exactly what it sounds like. They live for up to the entire life of the project. Every project has at least one long-running branch, and there is master. While topic branches are short-lived, and they are usually focused on a particular task, for example, a bug fix or a feature. Now, so master is an example of a long-running branch, and a feature is an example of a topic branch. Now, topic branches typically get merged into the long-running branch, and afterwards they disappear. So what you are left with is the fact that some work was done in parallel to the long-running branch. Now, there is another way to, there is another kind of categorization you can do with branches, and that is public branches and private branches. Now, again, this is pretty straightforward, but Git being a distributed source control system, you have a repository that is shared, your canonical repository where everybody pushes to, and that will live on a server like on GitHub or on Azure DevOps. And then you have your local personal repository that you're working on. Now, a branch that exists in a shared repo is considered a public one. That is a branch where multiple people are pushing commits into. A private branch is one that exists only on your machine. So they live and die on your computer. They're never published anywhere. Those are private branches. Now, long-running branches are typically public because, of course, they are branches where people collaborate. So they need to live on the shared repo. Topic branches are usually private. Those are the branches that you create on your machine to keep your own work organized. Of course, this is not the only way. You can have private long-running branches. So branches that you keep alive for a long time. And you can have topic branches where multiple people are collaborating. So they are public topic branches. Now, not all combinations are considered equal. Long-running public branches, definitely yes, they are good and they are necessary. The same goes for private topic branches. Absolutely use those. However, avoid having long-running private branches. Why? Because the longer you keep a branch to yourself, the harder it is going to be later to merge it back into the public branch. You're going to run into lots of conflicts the longer you keep it to yourself because nobody knows what's happening in that branch. And the long-running public branch is going to move along. So avoid having long-running private branches. The same goes for public topic branches. Now, if you have to, you have to. But in general, a topic branch is better used by an individual, or if you're doing pair programming, multiple people. But having people collaborate in a distributed fashion on a topic branch leads to a lot of complicated scenarios where people are maybe rewriting the history, they are rebasing, they are handling it in different ways. So absolutely it can work, but as a general rule of thumb, avoid public topic branches. This means that the guideline becomes be conservative with having long-running public branches, don't have too many of them, and be liberal with the private topic branches. Create as many as you want. The next one is related to merging. Now, this means let your branches decide how you want to merge them. Now, knowing that there are these categories of branches, long-running, topic, public, and private, depending on what they are, they should be merged differently. Now, you know that in Git, there are two ways to merge. There is something called the true merge, which is the one we did earlier. That is, you are creating a merge commit. The other one is doing a rebase, where you are moving commits and then you are merging by just doing a fast forward. Now, if you have a public branch that you want to merge into another public branch, you should most definitely use a merge commit. You want public branches that everybody see to be visible when they converge. When you want to merge a public branch into a private one, though, like if you're having your work in progress and you want to keep it updated with what happens in the public branch, then you absolutely want to rebase. Why? So for example, a public branch could be a pull request that you want to merge into master, and a public branch master merged into your work in progress. So what do I mean? If this is a public branch called master, and this is a pull request, there is also public because I want to have it code reviewed, so it gets pushed to the shared repo and it becomes a public branch where other people can comment on. When I want to merge my pull request into master, I want to do it with a merge commit. Why? Because, and then it gets deleted. If there is a problem later on, I discover a problem with what I merged, it is much easier to revert a merge commit with a new commit. You see the the inverse of an M is a W. This is a normal Git notation. So by reverting a merge, you can effectively undo everything that was done in the pull request in one single commit. This is, of course, much harder if I had rebased my pull request on master, moved the master forward, and then if there is a problem with the pull request, I need to revert every individual commit by itself. Of course, this is especially if you discover it later on when there are more commits happening afterwards, after F in this case, it gets even trickier to revert individual ones and determine which one was problematic. So another case, public and private branch, you want to merge them, and you want to merge the the public branch into the private one. That is your work in progress. If you do it through a merge instead of a rebase, and then later you want to merge your work in progress into master, you see what happens there? Double merge. Now, if you do this enough, that's why you want to rebase instead. If you do this enough, what happens is that you have a history that looks like this, with lots and lots of merges that just don't make any sense because you merged the public branch into a private one. This is called the Guitar Hero history. And why is it called Guitar Hero? Because it looks like this, even sometimes called Git Hero. You want a history that is clean and that doesn't have any more merge commits than it has to. The last tip or technique that you can do within your team is to map your branches to your release environments. And that means basically knowing where your branches are going, in which environment they are going. So let's say that this is the master branch and this is the develop branch. Those are two long-running branches. One is mapped to a QA environment where every commit gets pushed to some kind of environment where it can be verified. The master branch represents the stable version of your software. That means when you are merging the work that comes from develop that has been tested, you want to push it out to production so it can be used by your users. So you see, I have a clear mapping between my develop branch goes to test and QA and master goes to production. And of course, you can also do different kinds of deployments here. On the develop branch, you can develop every commit automatically. And in that case, you will do something called continuous deployment. While you probably don't want, of course you can, and there are many teams doing it, but you can push every commit that happens in master automatically to production. But what's more common is to have it master be in a state that can be deployed, but have it be a manual step. So at this point, you're doing continuous delivery. So you see, mapping, knowing where your branches are going and mapping them directly to an environment really helps collaboration and really helps getting the most out of your source control system to basically help your team deal with the lifecycle management of your software. So I'm running out of time. So let's wrap it up. I told you that effective teams, they have workflows that are divided into two categories: individual workflows, where the first one was a configure your environment, take care of crafting your history by creating ACID commits, and then let Git do the work for you by automating as much as possible of your workflow. The other kind of workflows are the team workflows. That is stuff to think about when you are deciding how you want to handle branching and merging in your team. So that means being aware of what kinds of branching you have, long-running, topic, public and private, and then base your merge strategies based on what branches you are merging. And the next one is having a clear mapping between your branches and your environments where you are releasing your software. And with that, I'm at the end of this presentation. I want to just let you know that if you are interested in more of this kind of techniques and ideas, I have a Pluralsight course out called Advanced Git Tips and Tricks. This requires that you have a fundamental understanding of how Git works. But here's the link. And with that, I want to say thank you for watching. And I think I have some time to answer questions. I haven't looked at the site if there are any. So I have 2 questions. Let me just open it up. So, sorry? Yeah. So the first one is, I haven't fully understood what keep index in stash save does. Can you verify? So what it does is that it takes all the modified files in your working directory and it stashes them away. However, it won't touch anything that has already been staged. So that's why it says keep index. And this allows you to get rid of all the modified files, stash them away, and then have only your staged file be in the working directory. And then you can run your tests and verify that what you're about to commit actually doesn't break anything. Afterwards, you create the commit and then you unstage your modified files. So hopefully this answered the question. Thomas says, Git aliases, I prefer saving my changes when undoing, as in alias wipe equals, and then there is a function. A comment, yeah, well, this is definitely a way to do it. I see that you are using the exclamation mark to basically whatever comes afterwards is going to be run as a shell command. And then you are using the double ampersand to say, if this command succeeds, then automatically execute the second one, followed by a third one. This is absolutely a good way to do it if you don't want to write a function. The reason to write a function is that if you want to pass arguments to your alias, like I did git undo with the number 2, this won't let you accept arguments. But if you write a shell function, then you have $1, $2, $3. Those are the arguments that you can pass to the alias. So in my case, I can say git undo 4, and it will do the operation for 4 commits. So that's why you want to use. So if you want to use arguments, define a function. If you don't need arguments, definitely chain your commands like this. Yeah. Are there any more questions? No. Okay. Thank you very much for watching and enjoy the rest of your day.